Hi everyone, this is Mrs. J, and today we're going to learn about angle relationships in circles. So first we're going to talk about the intersecting chords angle measure theorem. So this says if two secants or chords, so you can see here we have two chords, intersect in the interior of a circle, then the measure of each angle formed, so either this angle here, angle 1, or this one, they're vertical angles, so they should be congruent. The measure of each angle formed is half the sum of the measure of the intercepted arcs. So again, the intercepted arcs would be the arcs created by the endpoints of your chords. So this is one arc. This is the second intercepting arc. So you can see that we can find the measure of angle 1 by taking half the sum, meaning we add the measure of AB and the measure of arc CD. So let's see if we can apply this theorem in example 1. So here we are asked to find the measure of MPK, which is right here. So we can use the theorem above, and then we can say that the measure of angle MPK is 1/2 the sum of the two intercepted arcs, which would be arc KM and arc NL. So 61 plus 111. So therefore we know that the measure of angle MPK is 86 degrees. Okay, let's try part B. Here we're actually asked to find the measure of the arc. So here we know the measure of the angle. It's 58 degrees, and we know one of the intercepted arcs, and we need to find the measure of arc PR. So we'll still set up the equation. The measure of the angle, which is 58 degrees, is 1/2 times the sum of the measure of the two arcs. So we'll say 82 plus x, and this would be x. So now I would start actually by multiplying both sides by 2 to get rid of this fraction. So that gives us 116 equals 82 plus x, and now we just need to subtract 82 from each side, and we get x equals 34. So the measure of arc PR is 34 degrees. All right, so now let's talk about the tangent-secant interior angle measure theorem. So this says if a tangent and a secant or chord intersect on a circle, so here you can see we have a tangent, BC is a tangent, and we have a secant, AB is a secant, and you can see where they intersect at point B, it's actually on the circle, so a little different than the last one. And if they intersect on the circle at the point of tangency, which you can see that point B is the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. So this would be the intercepted arc, AB. So the measure of this angle, you can see the measure of angle ABC is 1/2 the measure of arc AB. So let's see if we can use this theorem for example 2 and 3. So here we are asked to find the measure of arc ABC and the measure of angle BCD. So let's actually start by finding the measure of angle BCD. So we know that the measure of angle BCD, that's formed when we have a secant and a tangent that intersect on the circle at the point of tangency. That angle is going to be half of the intercepted arc, which is 142 degrees in this case. So it's going to be 1/2 times 142 degrees. So the measure of angle BCD is 71 degrees. Now, we are also asked to find the measure of arc ABC. So here we're going to kind of go backwards. Here we actually know the angle. So the angle right here is 90 degrees. So we know that 90 degrees should be half of the measure of the intercepted angle, which would be arc ABC. So if you multiply both sides by 2, we get the measure of arc ABC is 180 degrees. So you can use that theorem either to find the angle if you're given the arc, or to find the arc if you are given the angle. All right, let's have a look at example 3. So first we are asked to find the measure of angle MPN and then the measure of arc PN. So let's start by finding the angle. So here again we have a tangent and a secant, and then we know that the intercepted arc, arc NQP, has a measure of 238 degrees. So we can use the theorem, and we know that the measure of the angle should be half the measure of the arc. So that means the measure of angle MNP should be 119 degrees. Now let's see if we can find the measure of arc PN. So here we have a different tangent line and then another secant. We know the angle formed, so that means that we can find the measure of the intercepted arc. So remember, the measure of the angle, which is 61 degrees, should be 1/2 the measure of the intercepted arc, which is arc PN. So then multiply both sides by 2, and we get 122 degrees for the measure of arc PN. So again, you can use this theorem to either find an angle if you're given the intercepted arc, or to find the arc if you're given the angle. All right, so now we're going to see what happens when we have segments that intersect outside the circle. So here, these are called the tangent, secant, exterior angle measure theorems. So this says if a tangent and a secant, or two tangents or two secants, any combination is fine, intersect in the exterior of the circle, then the measure of the angle formed is half the difference, meaning subtract the measure of the intercepted arcs. So in this first picture, you see that we have a secant and a tangent. So we can find the measure of angle 1 by doing 1/2 the difference of the two intercepted arcs. So that would be AD and BC. So we do the measure of AD minus the measure of arc BD. In the second picture, we have two tangents that intersect outside the circle, so we can find the angle by again taking 1/2 of the first intercepted arc, the larger one here, arc EHG, and then we subtract the other intercepted arc, the measure of arc EG. Remember, it's the difference of the two arcs. And then in this third picture, we have two secants that are intersecting outside the circle. So again, we can find the angle by doing 1/2 times the difference of arc JN minus KM, the two intercepted arcs. Okay, so let's have a look at example 4. So in this first example, part A, we're actually asked to find the measure of arc KM. So we can set up the same equation. The measure of the angle, 25 degrees, is 1/2 times the difference of the intercepted arc. So I'm going to do 83 minus x. And then I'm going to multiply both sides by 2. And then here, if we subtract 83 from both sides and then divide by -1, we get x equals 33 degrees. Okay, let's look here at part B. So here we're asked to find this angle, and it's two tangents that are intersecting outside of a circle. So the measure of the angle, x, should be 1/2 times the difference of this intersected arc, which is 238, minus this one. So now maybe you're thinking that we don't have enough information to solve, but we know that a total circle should add up to 360 degrees. So we can find that other portion by simply doing 360 minus 238. So this other arc has a measurement of 122 degrees. Okay, when you're simplifying this, again, make sure you follow order of operations. You should always do what's inside the parentheses first and then divide by 2. So here we get an answer of x equals 58 degrees. And last, for part C, here we have a secant and a tangent. So again, the measure of the angle formed, which in this case is x, should be 1/2 the difference of the two intersected arcs. So 161 minus 67. So here we get x equals 47 degrees. Okay, so just to summarize all of the rules, the theorems that we've learned today, if you have the two segments that intersect on the circle, then the angle measure is half the measure of the intercepted arc. If you have two segments that intersect inside the circle, like the very first theorem we learned, the angle measure is half the sum of the measure of the intercepted arcs. And if they intersect outside the circle, the angle measure is half the difference of the measure of the intercepted arc. So remember here, if it's inside, it's the sum of the intercepted arcs, and then here it's the difference. And then on this first one, it's just half the measure of the intercepted angle. So there's just a single angle to work with. Okay, so here we're going to be using a combination of all the theorems to solve for example 5 and 6. So in example 5, it asks us to find as many angle measures and arc measures as possible. So let's start by working with this secant and tangent that are intersecting outside the circle. So since they're intersecting outside the circle, remember the angle formed should be half the difference of the two intersected arcs. So this will actually allow us to find the measure of arc FD. So we can set up the equation 50, the measure of the angle, equals 1/2 times, again, the difference. So 150 minus the measure of arc FD. Here, I think the best option would be to multiply both sides by 2. And then if we subtract 150 and then divide by -1, we get the measure of arc FD is equal to 50 degrees. So now I'm going to add this in, zoom in just for a second. We know that this arc length is 50 degrees. We know that we can find the measure of this last arc because the arcs should all add up to 360 for a full circle. And so we can do 360 minus 64 minus 150 minus 50. And we can find that the measure of arc CD is 96 degrees. Okay, so now let's work with these two intersecting segments here and here. So here we have a chord and a secant that are intersecting inside the circle. So remember, when their two segments are intersecting inside, the angle is going to be half the sum of the intersected arcs. So here we know that the measure of this angle in the middle, angle BAC, is going to be 1/2 times, again, the sum of BC and FD. So 64 plus 50. And that gives us the measure of angle BAC is equal to 57 degrees. So that means this angle is 57 degrees. Of course, its vertical angle would also be 57 degrees. And then we can also find the measure of these two angles because we have a straight line, which should always add up to 180 degrees. So 180 minus 57 is 123 degrees, which should be the same as this angle below because they are vertical angles. And I think we have found everything we can find for example 5. So let's move on to example 6. So here we are asked to find the measure of arc PN and then the measure of arc KN. So if we want to start by finding the measure of arc PN, we can use this chord and this secant, which are intersecting inside the circle. So the measure of the angle should be half the sum of the two intercepted arcs. So we see the angle is 79 degrees. And again, it should be half the sum of arc JK and then arc PN. So we'll say 48 plus, I'll call this X. So let's start by multiplying both sides by 2. So we get 158 equals 48 plus X. So X equals 110 degrees. The measure of arc PN is 110 degrees. Okay, so now to find the measure of arc KN, we can actually use the same two segments, but we're going to look at them in a different way. So we're going to use these two segments intersecting, but this time we'll use arc JP and then arc KN, which is the other arc we're trying to solve for. So again, they're intersecting inside, so the angle measure should be half the sum of the two arcs. So maybe you're thinking, well, we don't know the angle measure, but we can easily find it because here we have supplementary angles. So again, any straight line, the angle should add up to 180. So if this angle is 79 degrees, this angle that is adjacent to it should be 101 degrees. So now we have everything we need to find arc KN. So again, the measure of the angle, 101, should equal 1/2 the sum of the two intercepted arcs. So we'll say 86, and I'll call it y this time just so I use a different variable. So again, let's start by multiplying both sides by 2. And then subtract 86, and we get y equals 116. So that means the measure of arc KN is equal to 116 degrees. Alrighty, so that is all for today's video. Thank you so much for watching.